the subject of basic of mechanical engineering, and today we have to study bucket pump, plunger pump and air chamber pump. Previous lecture we have to completed single acting reciprocating pump and double acting reciprocating pump. And this today we have to discuss about bucket pump, plunger pump and air chamber pump, which are covered in our chapter number 8, types of pump. We have different types of the pump we have to already study. The main two types of the pump is positive displacement and rotodynamic. These three types of the pumps are considered in a positive displacement pump: bucket pump, plunger pump and air chamber pump. Here first we have to study bucket pump, and normally we can say as a bucket pump or hand pump. There's a two name, bucket pump or hand pump. That's we have to know about the different component parts. First, here is a given a suction pipe. The suction pipe is directly connected to our bottom side pump, where we have to suck the water from the suction tank. And here is a given one suction valve, that's called as a one-way valve or non-return valve. It's give a one-time input and secondary time it's may be closed. This body part called as a cylinder. The cylinder is given to supply or flow of water from bottom side to top side of the piston cylinder arrangement. Then after the bucket or piston, here this arrangement is shown as a bucket or piston which give the support to flow water. Then after the one bucket valve, here is a one bucket valve is given. There is also a non-return valve or one-way valve which give the water supply only and only one direction, not to a both direction. Another side is maybe automatically closed. Then after the here is a delivery pipe, means it's give a water output from the cylinder. Here is a one given as a handle that we can to move piston in a upward and downward direction called as a reciprocating motion. Through handle, we give the reciprocating motion to bucket or piston, and it's transfer water from suction side to delivery side. That's we have to try to understand the basic principle and working of the bucket pump. A bucket pump is a single acting vertical reciprocating pump. There is a one type of the reciprocating pump, but it's a work based on a single acting reciprocating pump. It consists an open cylinder and piston with a bucket as shown in figure. There is a one cylinder and one piston arrangement. The bucket valve work on a non-return valve. This valve are work as a non-return valve. The both valve are work as a same, as a suction valve and as a delivery valve. There is a one packing, one stuffing box, and one Glen bush. It's a give the supporting to this pump. It's a not giving a leakage of water from whenever the water transferring from bottom side to top side. Let's you to show about the stroke. There is a two stroke. One is a inlet stroke and second is a discharge stroke. First, we have to consider the movement of piston. Piston movement is a reciprocating motion, like as a from move top side to bottom side and bottom side to top side. That's the movement of reciprocating motion, where the piston move from this one position to this second position. It's a move between this place. That's called as a reciprocating motion. What is about the intake stroke? The piston move up and the bucket valve remain closed. Whenever the move piston from its down position to up position, the first intake stroke, the piston move from its down position to up position. whenever we have to move our handle. During this position, the stroke liquid enter into the cylinder through suction valve. Whenever you have to move this cylinder in upward direction, it's create a higher volume. Here, it's create a higher volume. This volume are increasing by from first position to second position. Means this volume are increasing. Volume increasing, it's make a creating a lower pressure, and the vacuum are suck the water from the suction tank and enter into the cylinder. So what happened? The simultaneously the liquid above the bucket is forced into the delivery pipe through the delivery valve. પછી what is the next position? Here the sum of the liquid is there. Here some of the liquid is here. What happened for this liquid? Here some of the liquid is here. When the piston move from its down position to up position, whenever the water from upside of the piston is move or coming out from the cylinder through delivery line. Here the some of the water is there upside of the cylinder, and that's water are coming out from the delivery line. And after that do show the working of discharge stroke. Piston move downward direction and bucket valve are open. Piston move from its upside to downside. The secondary position piston move in a downward direction. Piston move downward. This stroke neither suction or no delivery of the water takes place, but the water which are previously sucked the cylinder move in upper side of the piston. Here the piston move from upside to downside. At this time, water neither suck and nor deliver. Means there is a no suction of the water are sucked from the suction tank and enter into the cylinder. And another side, there is a no water delivery from the delivery pipe. Only and only water are transferred from bottom side cylinder to top side cylinder. Only and only water transfer from bottom side of the cylinder to top side of the cylinder. Here, not water suck and not delivery from the cylinder. At this time, the valve of the bucket or piston are open and water transfer from bottom side of the cylinder to top side of the cylinder. Then after the we have to repeat the intake stroke, and at this time the water suck from the suction tank and exist from the delivery pipe. That's the working of bucket pump. Also, that's pump also called as a handle pump. Here is the animation file of the working of bucket pump. Then the first stroke, the water are transferred from the suction tank, and the another side of the piston, the water coming out from this position. Here, this position and this position are actively same time. Whenever the second stroke is active, the water are transferred from bottom side to top side. These are the secondary position. Okay, next we have to transfer next pump, plunger pump. Let's you to see the function parameter of the plunger pump. This is the drawing shown in the figure called as a plunger pump. These points are called as a suction of the plunger, and this point shown as a delivery of the plunger pump. Here the one cylinder and plunger mounted inside the cylinder. Here is a one plunger. Plunger is the one type of the circular rod like as a piston. But here is a we known as a plunger. Here is stuffing blocks and Glen bush. It's provided higher ceiling and not allowed to water pass from this way. Means it's a one type of the ceiling and prevent of the leakage. One of the packing is here. The packing is also called as a to protect the plunger from the atmosphere. One a gland bolt and gland. Gland is also give the one type of the isolated proof. Means it's not giving out from the water from this way. One is a handle to give the motion of the plunger, and one is a fixed link. It's give the support of handle. First, the plunger pump is similarly to like as a bucket pump or like as a single acting reciprocating pump. But here the volume of the bucket pump is larger. Here the volume of the bucket pump is larger. So it's give a maximum discharge at delivery time or at output time. But the pressure of this the flow is very low. In the plunger pump, the pressure of the delivery after the plunger pump is completed is very high. That's you have to differentiate from both the plunger and bucket pump. Let's you to know the working of plunger move upward and vacuum is created in this cylinder. Plunger move in a upward direction. Here the plunger move in a upward direction. What is the plunger area? Just we have to mention in a different color. This is the plunger area. That's called as a plunger area. And here very minor volume of the cylinder. This called as a minor volume of the cylinder. Meant that's the working of the plunger pump. It's a receive very low volume of the water and exist the very lower volume of the water, but it's a give a very high pressure for this flow. When the plunger move in an upward direction, the suction valve open and liquid enter into the cylinder. Here the suction valve open and liquid enter into the cylinder. For this way, the liquid pass from this way like as a suction valve and enter into the cylinder. Then after the start as a discharge stroke. For in the discharge stroke, plunger move downward direction. This plunger move in a downward direction. At this time, it's creating a lower volume and higher pressure. It's creating lower volume and higher pressure, and delivery valve open, and that's the higher pressurized volume are coming out from the plunger. Here the higher pressurized water are coming out from the plunger. There is a difference between both pump, plunger pump and bucket pump. Plunger pump Q is very high. Just you have to write for bucket pump Q is high and pressure P is low. Just 1 minute. Pressure P is low. What for a plunger pump? For a plunger pump, it has a Q is very small and P is very high. There is a difference between bucket pump and plunger pump. Bucket pump Q discharge is very high and pressure P is low. For a plunger pump Q is very low. Means there is a given a minor volume of the discharge or water at the delivery time. And the pressure for this pump is very high due to the higher length of the plunger and lower volume inside the cylinder. So it's creating a higher pressure. Just we have to show some animation file for clear our understanding and working of the plunger pump. Is the working of plunger pump. This portion are shown as a plunger, and these two balls are mentioned as a inlet and outlet. Here is the water or any liquid are enter through the suction line and enter into the cylinder through creating a volume by plunger. The another stroke is a plunger are moved downward direction and the high pressurized liquid are coming out from the plunger. That's the normal working of plunger pump. The next working animation file for a plunger pump. This point are mentioned as a inlet and this orange point are mentioned as a outlet. One time the suction open, water enter or liquid enter into the cylinder and plunger give the higher pressurized and then after higher pressurized, water are coming out from this way. And here we have to give the reciprocating motion is converted to a rotary motion and rotary motion are given by the external motor or external sources. Then after you have to study air chamber pump. This is the both type of plunger pump and bucket pump. You have to write one sentence for that. The plunger pump and bucket pumps gives a intermediate output. Plunger pump and bucket pumps gives intermediate output. That's the final sentence we have to write in the both pump. Then after we have to study air chamber pump. Here is a air chamber pump. This line is a suction line. This is a sump tank where is the water or any liquid we have to suck from this tank. One suction valve is given and one delivery valve is given to the pump. One cylinder and piston arrangement is given and two air vessels are mounted on suction line and discharge line. There is a two air vessel or air chamber are mounted. This portion is known as a delivery tank or overhead tank. This portion called as a delivery pipe and here is a suction pipe. The rotary motion are given to the piston cylinder arrangement to a converted in reciprocating motion. Yes, we have to start the working for air chamber. But during delivery stroke, the suction valve gets closed and flow from the suction pipe taken into the air chamber fitted on the suction side of the cylinder whenever is temporary storage. Just before you to understanding this sentence, is a normal pump like as a single acting pump. Thus, we have to removing both the air chamber. This arrangement look like as a single acting reciprocating pump. This arrangement looks like as a single acting reciprocating pump. What is the working principle of the single acting reciprocating pump? It's give a intermediate output from the SSC pump. But we have to change the flow types from intermediate to continuous output. So we have to put two air chamber from suction line and from discharge line to convert intermediate output to continuous output. Whenever the first stroke is start, the water suck from the suction tank and enter into the cylinder. Some of the water are enter into the cylinder and some of the water are stored in the air chamber pump as a temporary store. Here the air chamber are stored temporary base of water. Then after the next line is during the suction stroke, the delivery valve is clogged, but the delivery of flow, the discharge tank is continuous by the liquid discharge from the air chamber fitted on the discharge side. Here, for same this procedure, there is a suction valve open. In the another side, we have to show as the delivery valve is a closed whenever the first stroke is active. Whenever the previous delivery stroke are completed, the air chamber store some of the liquid here and it's released that liquid to delivery line in a continue. So it's give a continuous output from the delivery line. Then after the start, the second stroke, the water are pressurized and out from the delivery line. What at this time what's happened? The water coming out from the cylinder and get out from the delivery pipe, and some of the water are stored in a air vessel or air chamber. Then after the most of water are exited from the delivery line and enter at the overhead tank, and the pressurized water are returned back from this air chamber whenever the stroke are changed from intake stroke. That's a give a continuous output from the pump. So single acting reciprocating pumps gives intermediate output, but we have to convert this pump in a continuous output. We require a two air chamber vessel or air chamber fitted into the suction line and discharge line. Just I have to repeat once again how it's work. First, the suction stroke is active. The water enter into the air chamber and cylinder also. That's time, suction time, the water enter into the air chamber and cylinder. That's called as a suction stroke. Here the storage of water called as a temporary storage. After the completion of first stroke, the movement start is a second stroke. That's time the water are coming out from this way, and some of the water are stored temporarily based on air chamber, and most of water are exited from the delivery pipe to overhead tank. Whenever this valve are closed, the pressurized water are coming out from the air vessel and enter into the delivery line. Same for suction side air chamber, the pressurized water are returned back from this position and enter into the suction line. So suction line are continuously active, suck water from the suction tank, and the delivery line are also continuous working and give a continuous flow output from the pump. That's its convert intermediate output to continuous output. But the discharge Q are same for all time as a like a reciprocating single acting pump or air chamber pump. Just we have to see it's a working animation file, so it's a clear fundamental is a basic image, air chamber, delivery pipe, check valve, and drive pipe. And here is a wastewater. Here is a main line, like as a suction line or any discharge line. Here is a one valve is given to operate between the air chamber and outlet. Here is a given a one another valve to out the wastewater from the line. If the pressure are created higher, the some of the water are coming out from the valve. This is a waste valve. This portion known as a air chamber. This portion known as a air chamber, and this portion are as a delivery line. And this portion are known as a main line whenever the water are coming out from this place. Let's give the view the animation file. The water are coming out from this way, and pressurized water are goes to upper direction, and some of the water are stored in this portion like as a air chamber, and most of water are goes out from this way like as a delivery line. When this valve are closed, the water are comes down, higher pressurized or temporary storage water comes down and return back into the delivery pipe. So delivery line or delivery pipe gives continuous output. Some of the water are stored in air chamber, and another time it's out from the delivery line. Whenever the pressure is given by higher pressurized, the excess water are existed from this west wall, but this west wall are not active commonly. Whenever the pressure is go higher as per the critical level, then and then after its work. Otherwise, this west water wall are always in a closed condition, not in a active condition. This check valve or air chamber valve is continuously in active condition. Thank you.